class. Today we have a guest speaker who's come to talk to you about a whole bunch of science.
Yes!
Hi everybody, yeah, I'm Bree. Today we're going to try to make this as fun as possible for everybody. So let's get started. Recently our class has been talking a bit about the processes of washing and extractions, but some of the students are actually still having a pretty hard time understanding the differences between the two. So why don't you spend a little bit of time talking about them? Yeah, so basically in an extraction we are going to have two compounds in a mixture, and then we're going to add a solvent to help separate the two of them. There's going to be two immiscible phases, an aqueous solid and a organic liquid. One of them is going to prefer to be aqueous. Usually that's going to be your polar molecule, the more polar one, but sometimes you'll be like, oh, they're both polar. So what do I do about that? Basically in this kind of situation, you're going to want to add something to induce it to be more polar. So for an example, if you have a carboxylic acid and it's already polar, you're going to want to add a base, say NaOH is a common one, and it will make it become a carboxylic salt. And that'll make sure that it stays in the aqueous solution for sure, and then you'll know. And yeah, so anyways, we have an experiment set up for you right over here. We're just gonna head over there. So for our extraction experiment here, we have our separatory funnel, which in real life would be a cone-like shaped funnel that is sealed, but this measuring glass will have to work for this. We have some water inside of here, which is meant to act as our solvent. And then we have here the component that we are wanting to remove, which is flavors from this bay leaf here. You may have seen like bay leaves been used in cooking for soups and stuff. Usually you put the bay leaf into the soup and leave it there to cook with the soup, but then you typically don't eat the bay leaf. It's just meant to give extra flavor to it. And then I have some added food coloring on here just to demonstrate the flavors that would be extracted from it. So I'm just gonna place it right in here. And then, as you should be able to see, I'm gonna put it closer. The flavors are being extracted from the bay leaf into our solvent. That's kind of neat. And then over time, because we don't want to wait here forever, we will eventually have a mixture like this with our solvent containing just the extracted parts, and then this other part of our mixture, which is just our original bay leaf with no more of that food coloring or stuff we wanted to extract on it. So if we look at washing now, we are once again going to be using a solvent, but the solvent in this case is not used for the same purpose. It's going to be only used to remove the unwanted components of the mixture. So once the solvent is added, the only things in the solvent are going to be things we want to get rid of. We have another example set up right over here. Let's go. So here for our washing experiment, we got our separatory funnel, we got our solvent, which is just bleach, and we got, seems that I've actually forgotten to bring a compound to wash.
I spilled some orange juice on my shirt earlier.
Yeah, toss it on over. Nice. Now that we got our compound, we can get right to business. So we're gonna try to separate our shirt here from this orange juice stain. So we're gonna put it into here. I got a little bit of water in there because we're gonna make an aqueous solution here. Now we're gonna add a little bit of our solvent, the bleach. That is the complete process of our washing. It's all gone. I'll show you guys.